Welcome back to the channel. I got another customer's boards here, sent me a complete miner with 3 boards, and this is one of those cases where the boards get to me and they basically work, mostly, for the most part, so I'm just recording this and in hope that maybe there's going to be some stuff happening and we're going to find something about it on how to troubleshoot boards when they're being intermittent. So I got this metal board hooked up right now. I'm going to fire up the tester. And as you see, we got 65. So no fault on that one. Not now anyway. I'm gonna hook up this first board. Fire this up again. 65 again. So same thing for that one. I'm gonna go ahead and hook up this third board. Get these out of the way. And on this one got 64, so I'm gonna go put these 2 boards in the miner, and then we're gonna come back and do some more troubleshooting on that one to see what we got going on here. So be right back. Okay, we are back. I threw the other 2 boards in the miner and they seem to be hashing just fine for now, so hopefully we're gonna be able to catch them dropping or see what the problem is. So this guy, if we recall, was seeing 64 ASICs, and that is still the case. So I'm gonna go to the microscope, and what I'm gonna do, so here's 64 and 65. Oh, my camera's reversed. Hold on. There we go. Okay. So here's 64 and 65. So what I'm gonna do with the test running, I'm gonna check my signals coming out of 64. Let me just do like this. So from the top of the heatsink, I got clock, which is 0.87, which is good. That's CI 1.8, that's good. That's RO 1.8, that's actually good. That is BI. Or is that reset? Yeah, that is reset. So 1.8 reset is good, and this is BI almost 0, that is also good. So 64 appears to be doing good, and so we can probably suspect 65. Excuse me. So we can just check the powers real quick, even though it's pretty sure that it's good. So I got 1.8 there, got 0.8 there. Let's have a look on this side of the chip. So before 64, squeezing in there, again 1.8 there, and 0.8 there. So based on that, knowing that we got all the signals that appeared to be correct coming out of 64 and 65 not being detected, then we're gonna go ahead and pull the heatsink and see if we can find anything. See what the chip looks like visually. Doesn't look too bad. Let's have a look at 64 just for poops and laughters. And also these heat sinks were like perfectly aligned, so I don't think anybody's been in here before, which is always good. Alright, let's look at that under microscope again. So here's 65. You see what I see there? It's like a tiny little solder ball. Let me just get in focus for you guys right there. So was that when, actually I'm out of focus on my microscope. Let me just try to fix that. Yeah, there you go. So did that happen when I removed the heatsink? Maybe. Let's have a look at the rest. So see, this side has a couple too. They're not like touching the pins per se, but they're kind of stuck to this side of the chip. And these can definitely cause some issues. Okay, so that chip pins look good. How about this guy? Nothing really to notice here. A little bit of dust on this pin, that's fine. Right here, that also appears to be fine. Gotta get a little solder ball on the side here. There we go. Just give those a little cleaning, just to make sure we're not missing anything. Let's have a look at the tester again, see if that solder ball was maybe the issue. Nope, still 64. So based on that, I'm gonna go ahead and replace number 65 and see what that gets us. All right, we are back. Sorry I missed the microscope camera. And there we go, we see that's getting liquid. Almost there. Go. It's pretty shiny, so I'm gonna gently lift it. I'm gonna put that aside, and if the problem happens to be, let's say, not chip 64, then you can always reuse that chip and put it back where 64 is right now. Alright, so just lining her up slowly. Slowly, left to right. I am burning myself, which means I had to drop it. There we go, and I gently tap on it, and that helps it find its home. So right now, see, it's not moving, so surface tension is just put it where it belongs, really. So I turned off the air. I spent a little bit too much time there. You can see the flux is starting to cook, but oh well. So that is that. So we're gonna let that cool down for a couple minutes. Make sure we don't disturb anything in the meantime, and we will be back. Okay, here we are. Let's have a look under the microscope at how we did. I was burning my hand, I wasn't set up properly, and so I had to drop it a little bit sooner than I would have liked. But not bad overall, I guess. This side is kind of hard to see because of the light. Let me see if I can. Hold on, bear with me. I just changed the angle ever so slightly on the head of my microscope. Better? Yeah, kind of. Not really. Okay, so let's have a look. So it's still quite warm. I'm gonna gently cool off the top of the chip first, make sure everything is solid. Clean up this side, that looks pretty good. And then I'm going to gently go across here, make sure I don't rip any resistors. Just checking in my console, make sure I didn't rub any. I see a solder ball there on the top. Trying to get in between those two capacitors. Alright, that looks good to me. So that's all the ball. Yeah, that's all the ball. It's part of the top of the chip, so that's fine. Okay, so let's see if... Is that still too hot? Might be too hot, but let's give it a try anyway. See what we get. Zero. So yeah, let's let it cool down a bit and we'll be back. Okay, the board has cooled down quite a bit now. Let's try to fire this up. And still zero, so let's go to the microscope, make sure we did an okay job. And I'm just gonna go ahead and check my powers. So this is chip 65. And I do have 1.8 here, 0.8 here, coming out of 65, 1.8, 0.8, coming out of 64, oh, nothing here, and 0.8, but I do not have my 1.8 at the bottom here. Oh yes I do, okay, I just had a bad contact, so 0.8, 1.8, that is good. Oh, now the tester, let me just show that up to you. If we go back to the overhead, tester is back to 64, so so no change by changing chip 64. And let's have a look at the signals again, make sure nothing's changed between 64 and 65. So that was our, wasn't really a guess really, it was just a so here's the clock, 0.8, that's good. There's my CI, 1.8, that's good. RO 1.8, that's good. Reset 1.8, that's good. And BI 0, that's also good. So signals are still good here, but somehow we're finishing at this chip. So let's have a look at the resistors real quick. Just stop the test. Just make sure they're all there, first of all. And I don't remember the pattern specifically out of the top of my head, but see, I see okay, so this is not going to any other chip after 65, so maybe there's no resistor here. But I see between 64 and 65, I see 1, 2, 3 resistors, and after 65 I only see 1. But again, 65 is the last one in the chain, so you wouldn't have the resistors going to the other chip, so maybe that makes sense? Alright, let's do the easy thing and take the chip that was on 65 and put it on 64 and see if we get any better results. Alright, here is our victim. There we go, it's pretty good for you guys. Alright, so we're working around the heat sinks here again, so I gotta be careful at what we touch when that is all warm and fluid. Okay, let's fire up the air. Again, I got the initial chip that was on 65, made it right here, so that's the one we're going to use. So the top is becoming liquid. That's starting to be shiny, but still got a little ways to go. Especially in this corner right here. Alright, I think we are good. Not quite. Okay, grab it, we're gonna lift it slowly, just in case we need to reuse it again, because chips are expensive, so we don't want to waste any. And now, so this is the chip that was on 65 initially. There we go. You see how it kind of snapped into place, and now I tap it and it's not moving. So again, you just gotta let the surface tension do the work, and you just kind of help it, guide it a little bit. Okay, so that's it. Let's let that cool down and see what we got. Okay, I forgot where we left off exactly, but I did some more testing off camera because, as you can see, we still got 64. And so that's going to be a good example of why we should always trust our testers. So let's go to the microscope. So what I did off camera, let me make sure you guys are in focus. As good as it gets. Alright, so what I did, I made sure that all the resistors were there. So both between 64 and 65 and after 65, right? And then looked again at my solder job. So the pins look good, I think. So that's likely not the problem. And so what I did then, I tried to see if I could get 63 ASICs on the tester. So I took my RO right here, middle test point, and then I picked up the 1.8 volt out of that domain, which right here is good. And then firing up the tester. So my left probe right now is between chip 63 and 64. So in theory, by doing that, I should have 63 ASICs on the tester, but that was not the case. So I still had one less than what I was supposed to have. So I had 62. So if we go back to the overhead, let me recreate that setup. Start the test. Take the 1.8 and 62. So then I just went back. Let me just get my head in the way again. So I went between 59 and 60. So I should have, oh sorry, between 60 and 61. So I should have 60, and the tester right now says 59. So there's always one less chip than what I'm supposed to have. So that means that before 59 somewhere, there's a chip that's not communicating. So I'm gonna jump right here. So that should be 45. And I got 44 on the tester. So right here, that should be 35. And I got 34, so I know it's still before that. Right here should be 25. And now I got a solid 25. So I know it's between, do that again, there you go. So I know it's between 25 and 35. So let's split the difference. Split in half. So I'm at 30 right now. I got 29 on the tester. So I know the problem is going to be between 25 and 30. So there we go. So 26. There you go. 26 is good. And then I need to go I'm gonna stop the test. I need to go to the microscope to make sure I don't short anything. So this is 25. So we were in here for 26. So 25. Then the traces go around, right, on here on the side. So this is 26. So I was on this test point just a second ago. So we know that 26 is good. So now I'm gonna go right here. Try to go for 27, not that one. This one, make sure I'm in there, make sure I'm not touching any heatsink. I'm gonna take the 1.8 again. Oops, wrong domain, let's see. And 27 is good. So we're gonna go one more. This one's a little hard to see, but I'm gonna stop the test to make sure I don't short anything while I squeeze in there. And I can't really see anything. So apologies if you can't either. Let's zoom like right in there. Alright, it's as good as it gets. So I want to be right here. Oops. Alright, I think we got it right here. I'm going to start the test again. Find my 1.8. And now I got 0 for some reason. Am I on the right? I think I was on the right test point. Let's try it again. No, got a bad contact issue. I really don't want to have to take that heatsink off. Alright, let's go one more. And then hopefully sorry, I need to put my hand in front of the camera. Alright, so there we go. I'm gonna make sure we're not touching anything. I'm gonna take the 1.8 volt again, so this should give us 29, and it does. Okay, that's good. So let's try 30 again, which, let me bring you guys, zoom out a bit. Let me bring you guys to 30, which is this guy right here. Okay, so middle test point. Let's make sure you guys are focused. There you go, we're gonna make sure I'm having good contact. The tester still says 64 right now when I'm not touching anything, and when I'm touching the 1.8 volt. Now I'm still on 29, so let's recap what we had. So I went, so this is 26, so I started at 26 with my jumper between 25 and 26, or between 26 and 27 I mean, and took the 1.8 volt from the side. We had 26. I went between 27 and 28, and we had 27, which is good. Couldn't get into that one, so I went onto this one. So we had 29 here, and when I tried to squeeze between the two here after 30, then I still had 29. So there was no change from before and after 29, which tells me that chip number 30 might be our culprit here. So let's take a look. Let's remove the heatsink. Let's see what we got. All right, let's have a look under the microscope. Oh yeah, so that definitely does not look good. So there's like lots of dust on the one side, which is the dirty side, so that's expected. So basically when the airflow goes from the back of the unit to the front of the unit, or like from the intake to the exhaust, then it carries a lot more dirt with it, obviously. So this side is all dusty, but most noticeably there's like, all this is missing copper on the chip, so this is just bare. Oh, actually there's still a little bit underneath there in some places, but there's nothing here. Let's give that a quick clean. Wonder, is the copper still underneath that? Seems like it is in some places, but not everywhere. Let me grab a sturdier tool, see what we got here. It's kind of irrelevant because that chip appears to be broken, so no, there's really a big chunk missing. So you see the copper here, but there's a whole big chunk missing. So maybe that chip got hot, maybe I don't know, maybe it was just time for it to go. So it's interesting how, even though our tester said 64, we usually assume that the bad one's going to be either 64 or 65, but as we saw when we measured the signals at first between 64 and 65, then we had all our signals. So it kind of makes sense in retrospect that this wasn't the bad chip. So anyway, so what I'm going to do now, I still have the chip that was on 65, the one that I replaced initially. So I'm going to take that one and put it on 30 and see what that gets us. Let's do it. Okay. Same routine. A bit of flux, air, a little heat shield for my hand. And now we wait. This kind of looks like solder. Could be. But it's not melting like the actual solder, so. Who knows? Alright, here we go. And replacement chip, which is the old chip. There we go, we gotta line her up. Slowly tap it a couple times, move it a little bit. Oh, need to push it straight down, not sideways. Come on. There we go. Turn off the air. Yeah, no, that's good. Perfect. Okay, as usual, let that cool down, and we're gonna test it again. Okay, so I literally literally just moved the board back. It's still pretty warm. We're going to be really careful that we don't disturb anything, especially those little resistors, because we don't like replacing resistors. Big waste of time. Okay, so that looks good, I think. So again, this was the chip that was on 65 initially, or was it 64? That was 64 initially. So, and you can see it's still starting to get some discoloration in some areas, but it was fine on 64, so still looks good enough to be used, obviously. So let's see. Let's see what we got. Oh, actually the board is way too hot now, so I'm still gonna hook it up just in case it works, but I wouldn't be surprised that it doesn't. 64 again, so we're gonna wait a little bit, see if that chip is maybe too hot, which it might be, and then we'll test again. Okay, so the board is cool, and if we look at the tester now, 65, so we got all our chips fixed. So let's recap really, talk about what the problem was and why we shouldn't always trust our tester, right? So we started, the board said 64 chips detected. So in my experience, when you have an actual number of chips detected and when it's not a zero ASIC board, then it means that physically all the signals are connected, most likely, everything's got power, again, most likely. The problem is really just a chip that's not communicating. So, as you know, common sense or common knowledge says, if you got 64, then look at 64, 65, and one of them is going to be the problem, right? Either 64 is not passing on the proper signals to 65, or 65 is just not working properly. So we went ahead and measured the signals between 64 and 65, and everything there was fine, was checking out. And of course, we know that the power for this domain is fine because the 1.8 volt of that domain is also used by 61 and 62, 63, and those were working fine. And same thing for the 0.8. So 63 is using the same 0.8 as 64 and 65, and 61 and 62 is using the other 0.8 LDO at the bottom of the domain, and those were detected. So we weren't suspecting any power issue. But really a good technique, so what I just did earlier is I shortened my chain to 63, and then I realized that I was only having 62 chips detected. So that means that the problem is not 64 and 65, the problem was before that. And then I went ahead and did the same technique that we do usually, so split the board in different steps, and if you still have one less chip than what you're supposed to have, then you know that the problem chip is earlier in the chain. And so that's what we did. So we went 35, missing one chip, we went 25, and we had all the chips, so we split the difference. 30 were missing one, and then after that we went 26, 27, that was fine, 29, that was fine, and 30 was no good. So from 29 that was fine to 30 that was still saying 29, we were able to determine that our bad chip was number 30. So even though our tester was saying 64 initially, we wasted some time, replacing 65, then replacing 64. So that was completely useless in retrospect, right? And then we went on to number 30, replaced that, and now we got 65 chips. So the moral of that story is don't always trust your tester, or trust your tester that you only have 64 chips detected, but don't assume that it is number 64, 65. So hopefully you learned something from that.
If like me, you're fairly comfortable changing chips, and you usually have it first tried, and changing chips is a good test, I guess. If it only takes you like a couple minutes, then it's also a good troubleshooting test. And I reuse that chip that I took off and I put it somewhere else, and so I'm not really wasting any chips. And of course, the customer ultimately only pays for one chip replacement, even though physically, I suppose I did like 3 chips replacement. But I'm not sure going to charge him for my labor on that, because it's really my fault that I assumed that it was one of those two where it was completely somewhere else on the board. So yeah, so hopefully that was good for you. Hopefully you learned something. And if you got any questions, then put them in a comment or come meet me on Discord and we'll talk about it. Thanks a lot.